Hello everyone, and welcome to this very first module in our Chemical Engineering Economics and Project Management class. And in this segment, we will discuss some fundamental concepts about projects. So just to reflect back upon our mission as chemical engineers, so the primary mission of chemical engineering is to engineer and also to operate processes and physical chemical processing facilities so that the facility can be safely operated. It have a manageable environmental impact, and also last but not least is it has to be economically profitable. And the core job of any engineer is to identify, formulate, solve problems for the benefit of mankind. Design is actually just one of the ways that we as engineers perform our job, so therefore design should be dedicated to solve problems, not to create one, of course. And as you can see from the right hand side here, the engineering design process is an iterative one where we start with recognizing the need, and then we define the problem that needs to be solved. We plan the project, gather information about the project, and so on and so forth until we came up with a prototype to solve the problem, and we evaluate the test results based on the prototype. And if all goes well, then we will implement that solution. Okay. So this iterative process will always involve the selection of best solution from a reasonable number of alternatives. All right, now we go to the definition of engineering economics, and it is a branch of the science of economics, of course, that studies the application of economic principles to evaluate, compare, and select the best engineering solution from a number of alternative solutions. So in other words, engineering economics is a decision-making tool that we use in this engineering design process. Traditionally, engineering economics covers these following topics: cost estimation, cash flow analysis, time value of money, economic and profitability analysis, and also sensitivity analysis. Okay. Now let's see about the definition of a project as defined by PMBOK. PMBOK is an abbreviation for Project Management Body of Knowledge. It is a handbook that professional project managers has to be very familiar with, especially for their certification process. Right, and it's a very good reference. It's a free. You can you can download it freely from the internet, and it's periodically updated. Okay, so according to PMBOK, a project is a temporary endeavor undertaken to create a unique product, services, or results. And the temporary nature of projects indicates that a project always has a definitive beginning and end. Okay, there's no such thing as eternal project, proyek abadi. Okay, so and the end of the project is reached when the objectives have been achieved or when the project is deemed unnecessary to proceed. Okay, for some reason, for any reason. Okay, now temporary. The word temporary doesn't necessarily mean that the duration of a project is short. You know, you can have project that goes on for years or even decades. Okay, but it refers to the project's engagement and its longevity. Okay, and in fact, most projects are actually undertaken to create a lasting outcome. Okay, for example, here on the right hand side. Okay, so obviously, if you want to build a chemical processing plant, then you're not thinking about a plant that ceases to operate only within a few years. You want it to last forever if it can be. Okay, this is a bit wordy. Okay, general characteristics of a project, again, according to PMBOK, every project creates a unique product, service, or results. Okay, outcome of a project may be tangible or intangible depending on the project. Okay, although repetitive elements may be present in some project deliverables and activities, this repetition does not change the fundamental, unique characteristic of the project work. Okay, so even if a company does subsequent projects that seems to be repetitive, okay, that seems to be similar from one project to another project to the next one, there's always some differences between one project and the next one, such that it's sufficient to make each project is unique. Different circumstances, perhaps. Okay, different constraints, different geopolitical constraints, different location, things like that, you can name it. So each project is basically unique. And you can, I recommend you that you read the rest. I don't need to, this is a bit wordy again, so I won't go through all of the details mentioned here. You can certainly pause and replay this video to read this, the text better. Okay. All right, now projects and engineering solutions. A project provides a framework to develop engineering solutions, and these solutions may take the form of the following. It can be a product, okay? It can be a service or capability to perform such service. Okay, for example, a project may establish or may build a business function that supports production or distribution, for example. Okay, an improvement in the existing product or service lines, for example, a Six Sigma project undertaken to reduce defects to increase efficiency of a production facility, for example, and a result such as outcomes or document, for example, design. Okay, a design project will always result in document. Okay, so if you're asking what is the outcome of a design project, it's design documents, okay, or information, right? Now, this is the last slide for our current segment. So, project triple constraints. Okay, there's always these three aspects involved in a project. Okay, three elements that serve as objectives as well as constraints in the planning and implementation of any project, you name it. Okay, and those three aspects are costs, time, and scope or quality. Okay, so with respect to these constraints, a project must therefore be implemented with the definitive budget allocation. In other words, a project will always have a limited budget. Okay, a project must be completed within a definitive time frame, or in other words, again, the project has a limited time to be completed. And lastly, the project has to produce output in accordance to agreed upon specifications. In other words, it has to have a specific project scope. Okay, so all efforts in project management are basically directed to fulfill the above constraints. And you can probably start to imagine that it's not really easy. It's really not easy actually to balance these three aspects. Okay, and there's a reason why I put the picture of this Sydney Opera House here. And actually, this building, this magnificent building, is one of the most famous example of cost overrun and schedule overrun in project management. And the reason for that is that the scope, the project scope or specifications were not well defined. Okay, it was the specification was way ahead of its time in terms of buildability, in terms of the ability of the civil engineers to realize, to build this grand architectural features. Okay, so it's a very, very famous example of how not to do a proper project. Okay, all right, that's it for now, and we'll see you in the next segment. Thank you very much.